Good day, my name is Dr. Dupe Oseni, a master's student of space geophysics at INPE in Brazil, supervised by Professor Marlos Rockenbach and co-supervised by Marcus Oliveira Williams, Rosemary Oliveira. Today, I'll be talking about identification of flux rope from Parker Solar Probe data. Interplanetary coronal mass ejections are known as large-scale structures that contain plasma and magnetic fields that erupt from the sun. They are observed in situ in the interplanetary medium, and they have been proven to be connected with CMEs that are observed on the solar disk. Now, some of those ICMEs have been found to contain electromagnetic field lines, which is shown in this diagram. These electromagnetic field lines are known as magnetic clouds. Now, here on this left is a schematic picture of an ICME that was observed by the spacecraft on August 2014. In front of the ICME is a leading shock, which signifies the initial abrupt change in the magnetic field observed, and afterwards where we see the ICME enclosed in the red rectangular box. Now, some ICMEs are known to contain magnetic clouds, not all of them. And magnetic clouds in force approximation is described as symmetric force-free flux rope. This force-free absorption is given by J cross B equals to 0, where J is the electric current density and B is magnetic field vector. Now, it is important to identify ICMEs that contain magnetic clouds because they are often responsible for strong geospace storm, and they also provide a link to properties of erupting CME and source condition at the sun. So now we know that about 1/3 of ICMEs at 1 AU has clear MC signature, and sometimes these flux rope properties can be lost. So how do we identify flux rope? They're usually identified by these three characteristics when we observe them simultaneously in an ICME event. The first one is enhanced magnetic field when compared with ambient magnetic field, and the second one is the smooth rotation of the magnetic field direction, and the third one is depressed or low proton temperature and plasma beta. So now let's go to the Parker Solar Probe observation. At 0.25 AU, Parker Solar Probe encountered an ICME event during its first orbit. The boundary of these magnetic clouds were identified by visual inspection using the characteristics that were mentioned in the previous slide. On November 12, at about 0000 UT, the field instrument on the Parker Solar Probe data began to observe an increase in magnetic field, and which lasted until about 0640 UT. That means the event elapsed for about 6 hours, 40 minutes. This structure has a maximum magnetic field strength of about 97 nanotesla. And when we calculated the average magnetic field magnitude during this rate, it was 80 nanotesla, which is almost more than twice of the ambient solar wind magnetic field, which was just about 37 nanotesla. And also in the second panel, we saw that there was a smooth change in the magnetic field direction. And based on visual inspection, we noted that the magnetic configuration of this structure is a single flux rope with a south-north polarity. And the third characteristic is seen here on the last panel, where the sweep instrument measured a drop in the proton temperature. This low proton temperature is a common characteristic of ICME and is usually caused by the expansion of the ICME as it moves past the observing spacecraft, in this case, which is the Parker Solar Probe. Now, these three things signify that there was a flux rope in this ICME. And if you observe closely, we would see that there was no shock, there was no leading shock for this event. So, conclusion. ICMEs are very important in driving space weather disturbances, and they can be distinguished from ambient solar wind. Now, ICMEs may or may not have magnetic clouds. Flux rope are very important because they drive geospace storm and are found in most ICMEs. On November 11 to 12, 2018, Parker Solar Probe observed an ICME event which contained a single flux rope with a south-north polarity. Now, identifying this structure and their configuration, coupled with better understanding of physics of this eruption, will help improve space weather forecasting. Thank you.